Now this is a step-by-step tutorial to get the xAPI to send scores as well as feedback to SLS. So the first thing you need to do is you can use integrated development environments such as Visual Code Studio. So in Visual Code Studio, you can actually install something called Climb. It is one of the extension that you can find. So if you type Climb on it, then you click install, because I already installed it, so it will be there. Once it is installed, you need to configure it. The reason why I'm doing this is because I need to use the most powerful AI today in order to ensure that it's 100% accuracy. Because if you use Trade, which is running Claude 3.7, it doesn't guarantee you the one-shot accuracy. You can actually install for free. What you actually need is you need to come here after installing client. You need to click on the client icon, go to the board and select Gemini 2.5 Pro, whichever that is the latest and guaranteed to work. For the API key under Get API Key, and I will just click on it and copy it. So you can click on it and then copy it. Yeah, paste it in and then select the Google Gemini API provider and you are good to go. This is currently free for anybody to use. So you just close it, you just click on the AI model again. We have this particular file, which is the working file that is provided from SLS. So in this working file, it is already made to work. So you don't have to meddle with it. So essentially, I am reusing this code here because it could be too complicated for ordinary teachers. So I'm not going to explain how it works. What you need to do is after you copy it, you duplicate the index from the working and give it a copy over here. Index working and index are the two working files that are from this particular folder, which is in SLS info site as a zip file. This is also packaged together with the working xAPI file, so you don't have to worry about how it looks like or what it works. And this is an example of a simulation. So in this tutorial, I'm going to assume that you already have something that is built beforehand. Maybe it could be a simple interactive with a combo box and a slider for you to slide, and then you observe how the plant grow. So the trick is you have to tell the AI that this is working and this is also working. I need to find a strategy to combine these two to create the new index with the xAPI code that works. So how do I proceed to prompt it using this command line? Okay, then I'll say something like this. Using index as the working xAPI code base, do not modify the xAPI code. They are already working. I want to inject the index underscore sim inside of index.html. Sometimes you can shortcut by not repeating the .html. The xAPI is +1 for the use of the slider, because in this particular use case, it is a soy A and soy B. So I just show you how it can be done. You can just inform the AI that this is how I want the xAPI score to assign certain scores after certain actions are done on the interactive. So in this particular case, I'm saying that it's just a simple, trivial way of giving marks by giving 2 marks, one for each use of the slider. Then this is where it is important, and this is not going to be easy, but if you follow my step, you will find that you can achieve almost 100% accuracy and correct output in one shot. So the xAPI feedback is the string of action that is done on the user. For example, I would like to have like a t equal to 0, then the combo box is at what combo box, and then I also want the slider to know what is it, and then I'll keep on adding next line and so on, so that I am telling the AI through a use of a clever prompting by use of an example, so that the AI can understand what I want and so on. I want to use this xAPI feedback as a recording mechanism for understanding student thought process. So some of these words I will copy and paste into my blog or YouTube so that you can reference it. Reference, you meaning the AI bot client, which is Gemini. If you need to reference the correct working file, then I prepare a working file that's permanently there for code check. Because if you were to do this on a normal browser-based AI, it cannot reference different files and then do a difference between code and then understand what's happening, and then it cannot constantly refer to it. So to make the AI a little bit more clever by giving them something to work on that is always correct, so that as they build this file, they constantly can reference these two correct files. So the strategy is very robust, okay, because I'm giving permanent examples that will work for the AI to work with. Okay, and then the AI will say something like it understands, and then you can see the the planning by the AI is fantastic. This is the AI that can do very high level performance as an assistant. So then it will read the file, it will prepare the content by basically reading the correct SIM as well as the correct XAPI files, and then it will now inject it into, because I want to make sure that it doesn't modify this file. So I also prepared this XAPI index for it, and I ask the AI to insert the content inside here into the index file while not modifying the XAPI code. Because if you were to do this under normal circumstances, the code will fail because the AI will be too clever and come up with its own codes, and probably because the way the XAPI is designed in SLS, there is only a particular way that it has to work. So the strategy is to force the AI to use this and inject it into a correct base, which would inform the AI that it cannot change the XAPI code. Okay, so with this particular strategy, I have met with great success. So it used the base, but it adds the simulation code inside. After it has added, then it will do very clever things and read the other auxiliary files and make sure that it understands the functionality of what it does. Also, it managed to implement this correctly. So when the task is completed, it will say that it has finished its task, and then it will give you a summary of what it does. Just briefly read through, and then don't have to even see the changes. Then you just continue to ask the AI, double clicking on the index file. So once you double click on the index file, you will see that it has the soil, A and B, and then the slider. Okay. Of course, when you slide all this, nothing will be recorded and nothing will be sent to SLS because this needs to be injected as a interactive response question for it to work. So now going back to the VS Code, then you can see that it has now, I will cleverly ask it to zip up the index.js and the wrapper with a timestamp, and it is able to figure out. So you don't have to type on your own or rename the file yourself. Client is a bot that can run and execute code for you and then make the necessary changes, of course subjected to your explicit approval. So in this particular example, I need to click yes to agree to this file change, and then the code will be executed over here, and then the file will magically appear over here, okay, as the simulation. And I think that's about it. It complete this in double quick time, my assignment. So I could have injected it here instead as preview as student. We need to talk to the vendor to fix this. So as a teacher, you can just insert the file. So what you need to do, pause the assignment, agree, okay, then scroll to a particular position that you're happy with, come to this question. This is not the usual file from Drive, it's not this one. So if you do this way, you can never get it to work as a scorable HTML. So you need to use this question, free response, interactive response assistant, and then drop the file here. I'm going to drop my file over here, okay, and upload. Because I already know that this is a 2 mark question, so I will come here and change it to 2 marks, the assignment. So you need to close it, resume the assignment, make sure you resume. Okay, now you log in as a student. So this is a new interactive. You could change certain things. There could be some lag, but fundamentally it doesn't cause any error. So I will change to soy B. I will move the time and slide it a few times and then stop. Okay, and then you can see all the score. And then we slide a bit. Okay, then the score will be 2, and then it adds on to the timestamp of what the student did as a demonstration of the potential for very powerful analytics that can help you analyze what the student is doing. So together with the student, you can actually glean into what the student did and then be able to talk from the evidences of their teacher comment and then be able to come up with some kind of a strategy to discuss the evidence. So after you click submit, you will see that the score is 2, and this is the string of activities that the student did. So at time equal to 4, the combo box was soy B. When time was 12 seconds, the week was 1. And because the combo box never changed, so it didn't keep on adding and repeat itself. So at time equal to 15.5, the slider was changed to 5. And then when the time was 26, the combo box was changed to soy A. And then when time was 36, it was changed to time week equal to 4. So this is the feedback that I have demonstrated that it can be done in SLS.